Hello, everyone. Welcome, and thank you for attending this session today. You cannot hear us? Oh, cool. My name is Prajakta Damle. I'm the Principal Product Manager for AWS Glue. And with me, I have Arpan Shah. He is the Engineering Manager for Data at Robinhood. So we have a packed agenda today. We will be talking about building data lakes. I will be going over how Glue plays a part in building data lakes on AWS. And then Arpan is going to talk about how Robinhood built a data lake on AWS. But before we do that, let's do a quick refresher on AWS Glue. AWS Glue is a serverless data catalog and ETL service. It provides a data catalog, which is a central metadata repository that is Hive Metastore compatible. The data catalog helps you automatically discover the metadata associated with your data and then add that as table definitions to a central metadata repository. We also have ETL jobs in Glue, which are essentially jobs that run on a serverless Spark environment. AWS Glue helps you automatically generate scripts either in Python or Scala, and these scripts are entirely customizable. You can also bring in your own code and run it on the serverless environment that Glue provides. These are some of our customers. We have customers who are migrating their data warehouses to Amazon Redshift using AWS Glue. We also have customers who are building data lakes on AWS using Glue. And then we have customers who are using the ETL jobs in Glue to bring data from various different sources together, normalize it, pivot it, and make it available for their data science projects. This is what you're saying. As you can see from these quotes, Glue has been increasingly used in data lake architectures, and customers are finding value when they use AWS Glue, especially around reducing the operational overhead that they have. And we've been busy over the last year. We've added some notable features, like the metadata access policies to the AWS Glue data catalog, integration with Amazon SageMaker, a connector to DynamoDB to crawl the data in DynamoDB, as well as to use DynamoDB as a source for your ETL jobs, and end-to-end encryption. We've also made the service available in more regions. AWS Glue is now available in 12 regions worldwide. So now let's take a look at how to build a data lake on AWS. So a data lake is a central repository that allows you to store semi-structured, unstructured, as well as structured data coming from relational sources at massive scale. Not only does a data lake allow you to store this data, but it also supports a variety of analytics tools that help you derive insights from this data. And data lakes provide this at low cost. So with a quick show of hands, how many of you here are building a data lake or have an operational data lake already? Most of you. So this will be very familiar. These are some of the typical steps that our customers take when they are building a data lake. They have to set up their storage, a storage that can support a variety of data formats and massive scale. They have to move data from their data sources into this storage layer. They then have to clean, transform, and catalog this data so it's discoverable, and make sure that this data is accessed in a way that's compliant with their security and compliance policies. And finally, with a data lake, you want to make sure that the data is widely available to all the users in your organization across a variety of use cases. So let's step through these steps. S3 forms a great storage layer for your data lakes. S3 is an object store built to store and retrieve any amounts of data from anywhere. It is designed for 11 nines of durability and has the most comprehensive security and compliance capabilities. S3 also supports a wide variety of tools to analyze data at rest so that you don't have to move data or duplicate data. The second step is moving data to your S3 data lake storage. AWS provides the most amount of ways in which you can move data to the data lake storage in S3. You can move data from your on-premise sources using services like AWS Direct Connect, AWS Snowball, AWS Database Migration Service, and AWS Storage Gateway. You can also ingest and load data from streaming sources using AWS Kinesis, Firehose, Kinesis data streams, and Kinesis data video streams. And you can load IoT data using the AWS IoT core. But moving data and storing data is not enough. Gartner defines dark data as the information assets that organizations collect, process, and store during regular business activities, but generally fail to use for other purposes, like analytics. With the amount of data that organizations are storing today, and with the increase of machine-generated data, log data, the amount of dark data that is not discoverable and available for analytics is growing exponentially. So let's take a look at how AWS Glue helps you make your data more discoverable. As you can see here, Glue can help you take the raw data that you have in Amazon S3, process it through various different stages of curation, through the staging phase, where you are probably creating some intermediate results, to the processed and curated phase, where that data is now available, partitioned in a format that is optimized for querying and analytics in your S3 bucket. Glue also provides crawlers, and we'll take a deeper look at what crawlers are, to crawl and automatically catalog this data in a central Glue data catalog. And the Glue data catalog provides you a view into your data lake. It makes your data more discoverable through the search that is available in the AWS Glue data catalog. And you can enrich the metadata that is discovered by crawlers and add your own custom metadata in the Glue data catalog. So let's take a look at crawlers. Crawlers essentially scan the data that you give us access to, extract the metadata associated with that data, which includes the schema for your tables that are defined on top of your data. They also extract certain data statistics and discover Hive-style partitions for data that's stored in Amazon S3. Crawlers can be run on a schedule, so they can keep track of any schema changes, as well as pick up new partitions as they arrive. And they run on the serverless environment that Glue provides. You only pay for the time that the crawler actually runs. And crawlers come in built in with a set of classifiers that help them identify a wide variety of formats. But you can also write your own using Grok expressions. This is an example of a table that's been added by crawlers. This table points to a data set that contains Amazon reviews. And as you can see, crawlers have identified the format and added that as a classification. They have also added the location of the data. And they've added certain Hive Metastore compatible properties, as well as certain data statistics as table properties. Crawlers have also detected the partitioning key and registered the available partitions in the Glue data catalog. And you can add your own custom properties, like the one that I've added there, and further enrich the metadata and make this data more discoverable. Moving on to the ETL jobs that are available in AWS Glue, we've built a library on top of Spark that provides certain transformations that customers use to clean, reduce, and transform their data before using something like Spark SQL to run SQL-based ETL on that data. The library has dynamic frames, which are similar to data frames, but more optimized for ETL operations. And you can always run Spark without using the Glue ETL libraries. So in the libraries, we also have functions that allow you to convert a data frame into a dynamic frame or a dynamic frame back to a data frame. So you can mix and match and use the transformations that make most sense for your use case. The Glue ETL library also provides a connector to the catalog. So you can read a table directly into a dynamic frame and start transforming that data. And if all of this is not enough for your use case, you can always write custom transformations and import those as custom libraries in the Glue ETL job. The Glue ETL jobs can keep track of the data that it has already processed with job bookmarks. So if you have the job bookmark enabled on a source in your ETL script, the job can keep track of what data it has already processed and only process the deltas or the incremental data. You can enable the bookmark, at which point Glue will only process the deltas. You can disable the bookmark, at which point Glue will process the entire data set. Or you can temporarily pause the bookmark, which is often useful if you're doing some code modifications and you want to just test it without advancing the bookmark. You can also reuse AWS Glue ETL jobs by parameterizing the code that is part of your ETL jobs. The code is stored in your S3 buckets. You can use the same script across multiple AWS Glue jobs. And you can also trigger the Glue job, the same Glue job, across multiple triggers and across multiple conditions. So this is how you would use triggers in Glue. Triggers in Glue are entities that help you stitch jobs together. So jobs do the work, and triggers help you stitch different jobs together to build complex workflows. We have 3 types of triggers in Glue. We have a schedule-based trigger, where you can trigger a job based on the time of the day. We have job event-based triggers, which can watch for certain events from one or more jobs, and then trigger downstream jobs. And we also have on-demand triggers, which can be triggered through AWS Lambda on notifications such as the S3 put notifications. The triggers help you mix and match conditions using the controls that we have in Glue. So you can trigger when all of the conditions are met or any of the conditions are met. And you can also configure your jobs to be retried and have a job timeout to guard against any runaway jobs. And all the job metrics, which are Spark metrics, are pushed to Amazon CloudWatch, as well as available through the AWS Glue console. These metrics allow you to debug out-of-memory exceptions. They also allow you to identify data skews and help you plan the DPU capacity required for your jobs better. You can set up alarms for certain job conditions in CloudWatch and then take subsequent action based on these metrics. So now we come to the 4th step, which is securing your data once the data is prepped and discoverable in your data lake. So by default, all S3 objects are private. You can grant access to the data in S3 using a combination of resource-based policies, such as the S3 bucket policies, and IAM policies, the IAM user policies. You can also use AWS KMS to encrypt data both in transit as well as encrypted at rest. And you can use object tagging and enable tag-based policies to get access to the data that you have stored in S3. But securing data is only part of the story. You should also be securing the metadata that points to this data. And AWS Glue allows you to add IAM-based user policies for scoping down access to this metadata. Or you can also use the resource-based policies that are managed by AWS Glue, which are similar to the S3 bucket policies to scope down the access to this metadata. You have one policy per catalog, and you can also enable cross-account access using resource-based policies in AWS Glue. These are the resources that you can define permissions on. You can define permissions at the catalog level, database, or table level. You can also define permissions to access the connections that you have defined, the JDBC connections in Glue, as well as the functions. And here are some examples of what a resource ARN would look like for these resources. So the final step is making sure that your data is easily accessible to a wide range of applications in your organization, as well as to different teams and users. So with the Glue Data Catalog and the integration that it has with different services, your data is easily accessible through multiple different services. Glue Data Catalog integrates with Amazon Athena out of box. You can also choose to use the Glue Data Catalog as a metastore with Amazon Redshift Spectrum. And you can use the Glue Data Catalog as a replacement for your external Hive metastore with Amazon EMR. With the cross-account access, you can make the same view into your data available across multiple different AWS accounts and multiple different AWS users. So let's put it all together. You have your data coming from various different sources, and AWS provides a wide range of services to move this data in its raw form into Amazon S3. You can then use Glue, the ETL Jobs in Glue, to process this data and make it available for analytics. And you can catalog this data at various different stages using the Glue crawlers into a central metadata repository provided by the AWS Glue Data Catalog. And that data then becomes readily available through a variety of analytics services for your analytics needs. So with that, I'm going to hand it to Arpan to talk about how Robinhood built their data lake.
Thank you, Prajakta. So for those who don't know, Robinhood is a commission-free platform that allows users to trade cryptocurrencies, stocks, ETFs, and options very easily. Our mission is to democratize America's financial system, and making data-driven decisions is a big part of that. Today, I want to talk about why Robinhood needed a data lake, how we thought about it, how we ended up building it, our architecture that we used, and lessons and ideas that you can take with you, hopefully, and build your own data lakes on top of AWS. So to start, I want to talk a little bit about the world and what it looked like before Robinhood had a data lake. This might be a problem that many of you guys are familiar with. Data at Robinhood lived in silos that didn't very easily talk to each other. Many people call these data ponds. We had transactional data in Amazon RDS. We had analytics data in Amazon Redshift. We had files in S3, streaming data in Kafka, documents in Elasticsearch, and a bunch of third-party data sources as well. Data scientists, product managers, anyone who really needed answers from this data needed to learn the dialects for each of these different sources independently and try to figure out what these sources were talking about through these dialects. Even after someone had actually figured out these dialects, if they really needed to join across these data sets, they would have to put all that data in a central place and then go ahead and make those transformations or computations that they needed to get their insights. Another problem we were facing was we really needed to scale our compute and storage independently. For example, we had all our analytics data in Redshift. Our data started growing really rapidly, and very soon we were receiving terabytes of data every single day. Meanwhile, the use cases for this data weren't scaling at a similar rate, and as a result, we had the need to constantly upscale our Redshift instances as our data was scaling, not as the use of that data was actually scaling. This problem was not just limited to Redshift. We were seeing this across all the other places that we had data as well. On RDS instances, in our Elasticsearch, wherever we really needed to start querying our data, the rate of data growth at Robinhood was much faster than our use. And as a result, we were seeing ourselves scale this compute as well. This was becoming really, really expensive. And we really needed to have both those levers available to us. Finally, it became harder and harder to scale the number of users and govern their usage in a coherent manner. As people were accessing different data stores and accessing Elasticsearch on one day or Redshift on another, we had to maintain separate access patterns, ACLs, or permission groups for each of these. The overhead of managing all of these and keeping them in sync was getting harder and harder. And in a small company like Robinhood, this was a substantial overhead as we were adding more employees and more users on all our data. In addition, guaranteeing data quality was becoming more and more difficult. Since we didn't have a central place where schema evolution was being tracked, since we didn't have a central repository of all the different transformations that had occurred on the data, it was very hard for someone to know what the data lifecycle had been when they were actually using it. So as a result of this, close to a year ago, we started thinking about embarking on a journey to build our data lake. As Robinhood is extremely lean as a company, we wanted to make sure that we were doing this very methodically in a manner that would allow us to build out a solution that would benefit the customers within the company, at the same time do this very quickly. So this is the architecture that we have at Robinhood. We have 6 different components, and I can walk you through each and every one of these. First, we have the ingestion layer. We have a variety of different sources, as I mentioned earlier, that bring data into our system. Third-party sources, transactional sources, analytics data. We use a variety of batch and streaming flows to get this data into our storage layer, which happens to be S3. We use S3 for a lot of the reasons that Prajakta mentioned earlier. It offers us high durability. It's HDFS compatible. It offers bucket versioning, a lot of really nice features that make it very great for having a wide variety of data that is extremely different in various forms. Documents can live in the same place as your structured data. In addition to that, we decided to keep some of our data in Amazon Redshift for the more analytics-heavy, reporting-heavy workloads. Then we have the processing layer. We explored a bunch of different data computing frameworks, and we settled down on Spark as one that is extremely easy for us to maintain. It supports both Python and Scala, and it has a bunch of different dialects for both streaming processing as well as processing of batch compute workflows. We ended up leveraging Apache Airflow as our scheduler to manage these different jobs, and leveraged both Glue as well as EMR to manage our Spark workflows. Since Glue integrates very seamlessly into Athena, for our querying layer, we leverage both the Redshift interface that we have as well as Athena. And since we have the ability to use Redshift Spectrum and other tools, we can actually maintain this duality of having hot data in Redshift while we have other data in S3 that we can then leverage as needed. It's not just enough, however, to have your data and have it accessible. You really need to make sure that the data quality is very high. And for this, we built a custom validation layer. And this is something that has proven to be very valuable, because every time a new data set gets operated on or we have a processing step that takes place, we immediately validate to make sure that the data quality has not degraded. So this is data set level custom checks that we apply based on what the data should look like, what the qualities of this data are, and what we expect to be things that don't change. Finally, as I said earlier, we have a variety of users who want insights from this data. We want to make data to be self-sufficient, and people who need answers to be able to get them themselves. And for that, we have Jupyter Notebooks that data scientists and people who are very proficient in code can leverage, and Looker, which is our BI layer that others in the company who are analysts or product managers can leverage to get their own data. Let's dive a little bit deeper into the processing layer. In the processing layer, we took a largely hands-off approach where we don't manage much of the infrastructure ourselves. We leverage Apache Airflow to control the ETL jobs and scheduling. We leverage the Glue crawlers to start figuring out what our unstructured data looks like and store this metadata into the Glue catalog, where it is then versioned and allows us to know what the data changes have been, what are the new partitions that have been added, and have those all in sync in one place. Finally, we have serverless Spark via AWS Glue and EMR for really large customized workflows that both plug in very seamlessly into this data catalog so that as we add more downstream processing steps, it's very easy for us to actually leverage that same tool and the same library and the same framework, which is Spark, to get all of our work done. What's even better is that plugs directly into the querying layer. The AWS Glue catalog, as I said earlier, manages the partitions for you and updates them as needed so that when you're using Redshift or Redshift Spectrum or Presto, it's very easy for you to know what all of this data looks like and talk to it in the same SQL dialect. We decided upon Presto because of its ability to join across multiple data sources and its very efficient computation in memory. For the storage layer, since Presto can operate on top of S3, as well as can plug into Redshift, this makes it very easy for us to run queries across multiple data sets. Finally, as I said earlier, we have hot data in Redshift, and we have much cooler data that we occasionally need to access ad hoc in Athena and used via Presto. On Presto, to manage costs, we made sure to use columnar data formats like Parquet, as well as use compression, such as snappy compression, to make sure that fewer files need to be scanned, more data can be loaded into memory, and the queries that we're running are extremely fast. Redshift is already very optimized for queries, but as I said earlier, the cost scales as you have to scale both compute and storage simultaneously. We only keep the more commonly used patterns or reporting workloads in Redshift and rely on Athena for everything else. So I want to stop here for a second and talk a little bit about how I think a lot of companies and a lot of users can actually leverage Glue in similar ways and can offer a lot of value for people who want to build data lakes with a lean team or get started with working on data lakes. Taking a step back, the key element of data lakes that is very powerful is that it enables you to both keep track of raw and unstructured data as well as structured data. In the past, in more traditional use cases where you just had a data warehousing approach, the schema of the data was very closely coupled with the actual usage of the data. So you had to upfront think about how all the different data patterns would be, and then choose a data warehousing solution that would then suffice for all of these different data needs. With a data lake, you can actually keep this raw data in the original format that it appears in S3. And then as individual use cases appear, you can then process those for the actual use case that you care about. This allows you to make sure that in the future, if a new use case emerges, you still have the raw data. And so you can process this as you need to for that individual use case down the road. Glue actually makes this very, very easy for you. It seamlessly plugs into a variety of data formats. It plugs into Parquet, JSON, CSV, project I mentioned, grok patterns as well. So no matter what your data looks like, Glue can apply the schema that it actually holds after the fact. In addition, you have the catalog that plugs in to your EMR or your Spark or any other distributed data computing library you care about. And then you can use those to process those individual workloads as needed down the road. In addition, going serverless allows you to focus on building. The entire data lake at Robinhood over the last 6 or 7 months was built by just 3 engineers. We now have over 15 data sets that shipped in the last few months, and over a petabyte of data that's in compressed format. In the beginning, when you're starting out building data lakes, it can seem a little intimidating to take all of this data that you have, put it into one place, and then provide so many use cases on top of that. Glue actually minimizes the operational overhead for you. You don't need to tune clusters. You don't need DevOps resources off the bat. Your engineers can focus on learning Spark or whatever framework that you care about. And finally, in the beginning, when you're building data lakes, it's really normal to see spiky data patterns. You add a new data set, the amount of data processing you do suddenly spikes 2x's, 3x's routinely. You don't have to keep tuning your clusters or tuning your workloads every single time. You have a serverless environment. You throw data at the problem, and it just works. In addition, as I said earlier, and this might be true for many people here, you might have a multi-destination data solution in mind. You might want to use Redshift for certain kinds of data loads. You might want to use Presto or Athena for other data loads. You might even use EMR. It's very important to have something that can actually plug in very seamlessly across the board. Amazon Redshift, for us, handles small mutable data and reporting workloads, and ad hoc models or extremely large data set queries that need to run happen on Athena. Glue actually provides libraries out of the box that plug into each and every one of these. And because the data catalog also integrates with all of this, your schema transformations that are happening as data grows is also integrated very seamlessly into all of these different use cases. In addition, since it plugs very seamlessly into Athena, as I said, you out of the box have a querying layer as soon as you start building the data lake, so that your users actually see value on this as soon as you start building it, as opposed to months down the road when you hope to provide value. So if you do decide to use AWS Glue for your data lakes, here are some key learnings that we felt are really valuable, and hopefully they can help you as you're building your own data lakes. Firstly, it's very important to set up testing, version control, and a dev environment very early. Since you're in a serverless environment, a lot of these things don't come out of the box. For example, versioning doesn't come out of the box with AWS Glue scripts. So what Robinhood has done is we have Jenkins builds that occur as soon as every commit lands into a centralized repository that keeps all our Glue scripts. Because we have version releases, these all end up as a separate path in S3. And when we need to roll back or we catch a bug, it's very easy for us to do this by just pointing the job to a different path where our version script lives. In addition, Glue provides a development endpoint. And this is really valuable as engineers are starting to work on data sets. You really want to have the ability to play with the data to get a feel for what it is as you understand and try to build your workflow on top of this. This is something that's been really valuable at Robinhood, and I would highly recommend setting this up for your developers so that they actually understand and can play with the data before they send off their script into a serverless world. In addition, Glue allows you to package shared library. So if you see common code patterns emerging, it's very advisable to kind of bundle these into a shared library that you submit with each and every one of your Glue scripts. So your Glue scripts are not repeating code, and they're reusing code as much as they can. In addition, I would recommend not being afraid to complement AWS Glue with Amazon EMR as needed. AWS Glue, while it abstracts so many things away from you, it does limit the amount of configuration and configurability that you have. For example, AWS Glue does not allow vertical scaling just as yet. And there are workloads, for instance, at Robinhood, when we had to work on a large amount of our analytics data, which was in many, many terabytes, you might want to tune the CPU and memory balance and have fine-grained control over that. And for use cases such as that, EMR can give you a lot more configurability. In addition, extensive executor logs that are sometimes necessary to debug when issues arise are not easily visible in AWS Glue, and you might want to use EMR because it gives you a lot more understanding of each and every step that takes place in your Spark job. And if you have custom configurations of Apache Spark, or you have a team that actually can support it, and you really want to have your own version of everything that's running, EMR can give that for you. So highly recommend using that, especially if you need additional Spark functionality, things like Spark UI and other things. It's also very important to monitor the jobs and data that you have very carefully. Since Glue makes it so easy for you to get started, it's very simple to forget that you still need to understand what's going on underneath the hood. For example, you really need to know what the crawler is doing. You need to know what a DPU is. And these things all tie in very closely with the metrics that Glue exports that you really want to keep an eye on. For example, if you don't really keep an eye on it, it's very easy to overuse the crawler and start seeing much higher costs than you need. If the schema that you know does not change, you can just add partitions directly and not wait for the crawler to detect these, because you already know what the data is going to look like. In addition, as you start monitoring your SLAs and you start seeing that your data grows, you might start seeing your jobs take longer, and you need to adjust the DPU allocation that you have for your jobs on the fly. So it's very important, even though this is serverless, to kind of really have your eye on all of these metrics so that you're kind of tuning this and making sure that downstream customers aren't impacted as your data grows. At Robinhood, we use a very powerful scheduler to manage our AWS Glue jobs. We leverage Apache Airflow to manage complicated DAGs of different AWS Glue jobs. This is very powerful because we don't just use Glue to take a certain data set and make it available. We often have multiple data sets that kind of build on top of each other. And managing these dependencies, making sure that they kind of all plug in together, is very important. we were already using Airflow to manage other computation jobs and tasks that we had. So using a scheduler that works for you, for your company, that plugs in already into the existing development environment that you have is really, really important. Your scheduler should ideally alert you upon failures, enforce SLAs, have retry logic. One particular feature that is really powerful for us in Airflow that I definitely recommend is the ability to set concurrency limits. On your AWS account, you might have a certain number of DPUs that you hope to be using at any point in time. Airflow allows you to set separate queues for the different data jobs you need. And so you can have a high data or high DPU job, a low DPU queue, a medium DPU queue, and then set concurrency limits on all of these so that your lower DPU jobs don't overwhelm the higher ones, or vice versa. And you have a limitation on how many of each to run at any given point in time. That way, you're ensured that your jobs will not wait for DPUs, or you will not exhaust your resources when you don't expect them to. So finally, to draw it all together, I want to talk about how using AWS and these serverless technologies, Robinhood was actually able to achieve a data lake in a very short amount of time. We have solved all the issues that I pointed out earlier. We no longer have data silos. Scaling our users and scaling governance is a lot easier. And we have been able to separate our compute and storage so that costs are a lot more manageable. In addition to that, we have been able to build a lot of new applications on top of our data that weren't possible before because of how united our data is now. People don't need to have different dialects that they understand. They can write SQL across the board and build on top of things with a unified framework such as Spark. If you're interested in this and want to learn more about this, we have another talk tomorrow at Startup Central that dives deeper into specific details on how we actually ended up building each and every one of these components. And if you're even more interested, definitely come talk to me afterwards, since we're hiring in the data team at Robinhood. With that, I'd like to thank you guys, and Project and me will be around to answer any questions that you guys have. Thank you.